In this video, we're going to talk about probability and occupancy problems. The probability of an event is the number of possible outcomes where occurrences signify the event divided by the total number of possible outcomes. Let's start with an example. A fair coin is flipped twice. What is the probability that at least one head shows up? What about the probability that no head shows up at all? Let's draw a simple diagram to illustrate what's happening in the story. So when a coin is flipped once, the outcomes are going to be head or tail. So I'm using H and T. And then when it's flipped a second time, again, the outcomes are going to be HT, HT, head, tail, head, tail. So these are all the possible cases that might happen. If we want, so now I can use a paired order HH, HT, TH, and TT to represent what's happening for the outcomes. Now, what is the probability that at least one head shows up? We have 4 outcomes in total. So the probability of at least one head shows up is going to be the first result would work, the second one will work, the third one will work, but the last one won't. So it's 3/4. That's a probability for this event to happen. What about the probability that no head shows up at all? Well, that corresponds to the last case, in fact, so it's 1/4. And you should notice in this problem, the sum of these two probabilities add up to 1, and this is not a coincidence. It's because these two events are complement to each other. So here it is, complement. If EC is a complement of the event E, then the probability of EC is 1 minus the probability of the event E. Let's take a look at the next example. A fair coin is flipped n times. What is the probability that at least one head shows up? What about the probability that no head shows up? In fact, over here, it's very similar to example 1, except that there are n many flippings happening. We're going to take care of the probability that no head shows up first, since this is kind of easier to figure out. Because if you want no head to show up, then all the outcomes for each flip should be tail. And that's going to be 1/2 to the power of n, or you can write it as 1/2 to the power of n. And this tells us the probability of at least one head shows up is going to be 1 minus it, because they're complement to each other. Next, a fair coin is flipped twice. What is the probability that exactly one head shows up? If you still remember the outcome that we recorded in the first example, then 2 events, we have head tail or tail head, will correspond to what we want in this example. So the probability of exactly one head shows up is 2/4. In other words, 1/2. Next, a fair coin is flipped n times. What is the probability that exactly one head shows up? Okay, so in order to figure out this, we're going to first talk about how many ways could this exactly one head show up. Well, the coin is being flipped n times, and each time the coin is being flipped, the head might show up. So there are n choose 1, in other words, n many possibilities for this one head to show up. Therefore, the probability of exactly one head shows up when you flip the coin n many times is going to be n choose 1 divided by the total number of outcomes. So that's 2 to the power of n. In other words, n/2 to the power of n. And this is consistent with what we found in example 3. Now let's move on. Example 5. A coin is flipped 4 times. What is the probability that half have heads? What if the coin is flipped n many times? So let's worry about the first case. When the coin is being flipped 4 times, we want half of them have heads. So let's think about when or how many possible ways could half of the heads show up. It's being flipped 4 times. So the number of ways for this to happen is going to be 4 choose 2. Out of how many outcomes in total? Out of 2 to the power 4. And you could simplify this to 6 over 16. That's 3 over 8. And of course, for this question, you could, in theory, also draw a tree diagram like what we did in example 1. So you start with the first flip. Here are the possible outcomes. And then you flip a second time. And then you flip a third time. And then you flip it the last time. So all the possible outcomes are here. And then you can just simply count. Okay, I'm running out of space here, but you'll get what I'm trying to do. So now you can simply count what is the probability that half have heads. And then now in general, if the coin is being flipped n times, so half have heads. If it's being flipped for n many times, you have to pay attention to this n. Now, if n is odd, this is going to be impossible for it to happen because half of an odd number wouldn't make sense. So we only care about the case when n is even. Okay, so out of half of this n many events, so we're going to choose half of them. That's the number of ways for heads to happen, divided by, again, the total number of outcomes is 2 to the power of n.